Okay, so we're talking about circles, and I asked you to draw a circle at the very center of a graph like this. And now I want you to label your circle like this. It's a little bit fuzzy, and I'm sorry about that, but label it with have a little triangle right in here on your circle. If you drew yours too small, you got to blow it up and make it bigger. This is x. Do you get why that's x? Because it's the distance along the x-axis, right? And this height here is y, and that makes sense too, because it's the height. The only one that really doesn't make sense is that this is 1. Why should that be 1? If you make a circle that has a radius of 1, then that distance would be 1, right? So at this distance, so at this distance, so at this distance, all of these are radii, I'm talking about. But this triangle now has sides of x and y and 1. Now, what do we know about right triangles? That a squared plus b squared equals c squared. So then x squared plus y squared should equal 1. 1 squared. But 1 squared is 1, right? So would you please take this, and why don't I just say that's the equation for a circle? It is. But the problem with it is that normally our equations that we put into a calculator start with y equals, right? Then all you have to be able to do is solve this thing for y. So everybody write this down if you haven't already. And now we're going to take away x squared from both sides. And now, some of you are falling behind. And now I have y squared equals 1, which is, 1 squared is just 1, so I'm just going to say 1, minus x squared. I'm really close to having y alone. What do I need to get y all the way alone? Square root. When I do the square root of both sides, some of you are going to still forget and think that this is y. It's not y. What is it? Y, it's the absolute value of y. Remember that? Got to get that through your head. You're going to see it over and over and over. And in pre-calc, we'll do it over and over and over. You got to know that's absolute value or you're going to keep losing points. Okay, square root of 1 minus x squared. Now, what does an absolute value mean? It means that the answer will be positive and negative. So this one comes out to y equals plus square root of 1 minus x squared, and y equals minus square root of 1 minus x squared. Now, that's something you can actually type in on a calculator. You don't need the plus there, right? But it is positive. Type that in on your calculator. It's half a circle. That's right. Everybody get your calculator out right now. Yes, your question is? 1 minus x and x minus 1 are not the same thing. Oh, I know what you're thinking. You're thinking you could take the square root of 1 minus x squared. You can't. Because you can't just break up and take the square root of this and the square root of that. It would be sort of like this. If we had the square root of 25 minus 16, you can't say, oh, that's the square root. That's the same as 5 minus 4. Get what I'm saying? It does seem like it should work, but it doesn't, because 5 minus 4 would be 1, and you know that that would not equal 1. Okay? All right, so can't do that, but that was a good idea. So now, when you type that into your calculator, 1 minus x squared, all under a square root, it'll look like that top one there. 1 minus x squared. And it's a really small circle. All right. To complete the circle, the first one is the top half of the circle. Arrow down to the second here. There we go. And on your y sub 2 line, put in negative square root of 1 minus x squared. Use the negative key, not the minus key. It doesn't like it if you use the minus key at the wrong times. Then, when you hit graph, if yours isn't as pretty as mine is, it's because I used a special kind of zoom. If I just do zoom 6, it will look squished. Why? Because have you ever noticed before that the x-axis and the y-axis have different space tick marks on it? They're not the same spaces. If you want it to be square, like you really probably should want it to be square, you go zoom square, which is number 5. And now it makes it a perfect square, as in the tick marks are the same distance. And now it's just kind of small, and so if I want it to be a nice looking circle, I might want to zoom box it or something. I could just do a zoom in, actually. That'd be easier. Zoom in, and ask me with a blinking thing, where do you want to zoom into? I want to zoom in right to the middle, so I hit enter. And there I go. I got a nice circle. All right. But notice it took 2 equations to make that circle. Do you know why that is? It's because the circle is not a function. If you think about this, the circle's not a function because it doesn't pass the what? Vertical line test. All right. So it has to be 2 separate functions put together. When you take the top part and the bottom part, those are both functions. So if you take the top part and the bottom part together, you'll make a circle. That's why it takes 2 equations to do it. All right. So this x squared plus y squared equals 1 is what we started with. Now, what if I wanted to move this circle somewhere else? If I wanted it to move, this is what I would do. If I wanted it to move to the left or right, I'd put a number there. If I wanted it to move up or down, I'd put a number by the y. Does that make sense? And then if I wanted it to have a bigger radius, I'd put the radius there. So here's an example of a circle that's been moved 2 to the right. I'd say x minus 2 plus, and if I wanted to move it like up 5, you would think I'd put plus 5, but I put minus 5. That'll move it up 5. Yep, because it's on the inside, and things on the inside are counterintuitive. Which kind of makes sense. You're used to doing these counterintuitive. Now you got to do these counterintuitive also because they're on the inside. Equals, and let's say I wanted to have a radius of 4. I would put 4 squared there. Be careful. Some people think, yeah, 4 squared. It's a classic case. All right, so if you put that into a calculator, the hard part would be you'd have to solve it for y, which would be a real pain in the butt. And you'd get 2 equations and blah, blah, blah. But this is what's called standard form for a circle, is where you have something like the x part, then the y part, and then the radius. All right, so h and k represent the places you want to move it to. The really cool thing is, what do you think 2, 5 is? The center of the circle. And then the radius in this case is 4, so the whole distance across the thing would be not 16. Be careful. The radius would be 4, so what's the distance all the way across? If the radius is 4, then the diameter would be 8. All right, but anyway, the center of the circle is this spot right here. All right, so what that means is, if I gave you an equation like this, usually you start with the x, so let's try that. X minus 3 squared plus y minus 17 squared equals 144. Now, you already get this well enough, and if you get the whole when things are on the inside, they're counterintuitive, you'll be able to tell me this is what shape? Circle. And its center is where? 317. And its radius is, be careful, 12. Because 12 squared would be 144. So the radius isn't 144, it's 12. It's something squared. All right. So on the other hand, if I said I wanted a circle that was at 2, 1, and I wanted to have a radius of 6, write me an equation for that. If its center's at 2, 1, and its radius is 6. JS, get me started. Nope. Thank you for trying. Minus 2. It's okay. You had a 50-50 shot, and I know you were thinking, okay, should it go the opposite way or should it go the normal way? If this is a positive 2, then you have to do counterintuitive. Remember, because it's on the inside. All right. Squared plus, now I bet you can do the y part. Yes, if you write, say, 6 squared, then you're right. Or you could say 36. Okay. So here's a harder one. Let's say I had said 2, -1. What would change? This would have to be a positive 1 then on the inside. All right. Good enough. So these really aren't that hard. The only other thing that they ask you about on these kind of questions is the domain and the range of it. And domain and range are really easy. They're left and right? So how far to the left does this thing go? Careful. What's the smallest it ever is? -3. To the farthest to the right it ever goes? So the domain on this thing would be -3 to 3. And does it get brackets because it actually touches? Yes, it does. And the range, -3 to +3 again. So this time it's from down here to up here. So it's -3 to +3 again, brackets. Yes. Think about it, if it's a circle. Well, wait, I should clarify. They'll always be the same distance between them. But if you move the circle, and the circle is like there, then its domain is from -4 to +1, 2, 3, 4, 5, 6, 7, 8, 9, 10, actually. From -4 to 10. Not 110, 10. That'd be its domain. And its range is still the same distance, but it's a total of 14. But it isn't necessarily, see, this one's at 3, 3 again. Hang it. If I would have had it moved like to not a spot that's the same distance this way and this way, like if I had it like over here, circle right there. Its domain is from here to here, its range is from here to here, and those can be totally different numbers, but the distance between them will always be 2. Okay, anyway, so to finish this problem, will be the center of this circle, 3, 3. The radius of this circle, 7. And its equation, therefore, would be x in parentheses plus the y in parentheses, and those are squared, equals the radius squared, which would be 7 squared. And then I just got to finish it. I put the center right there, so it would be oh yeah, don't look at the domain for that. Okay. All right. I think you know everything you need to know for today's homework. So the homework is a worksheet. It's right here. And then we are getting done in time. Well, I can show you your test really quick.